Welcome to this Maths Heroes video. My name's Christine. Probably more than 10 years ago, I hate to admit it, but I had algebra tiles and I was so enthusiastic about using them, and the kids still looked at me blankly with their faces, and I thought, but I've just done hands-on materials, why didn't it work? And I've since uncovered and learned that actually if students don't understand how to do it with numbers, showing it with these tiles, these abstract pieces, didn't really help them a lot. So what I've got here is, I'm going to show you a series of images and see that we can find a pattern. So here I've got 10 tens, 3 tens. I've actually got 10 twos, but now I can flick it over and it becomes 2 tens. So now each of these 3 pieces are the same size unit. So a lot of kids have a misconception that X is always 10, but I could actually do that with a 5 as well. And ideally I'd space these out so they'd be next to each other, so we could compare. And again, now I've got 5 twos, that is also 2 5s. So this time I've got 8 by 7. The original one was 13 by 12, and it actually doesn't even matter what size pieces I use. That same idea keeps coming up. So this time I've got 11 and 10. So let's have a look at what I'm actually doing. The first one that I had was 10, 10, 3 and 2. So this was 12 by 10 or 10 by 13 by 12. So here I've got 10 tens, which was 100. Here I've got 3 tens, 10 threes, I had 30. Here I had 2 tens, 10 twos, which was 20, and in this last place I had 2 threes, 3 twos, which was 6. The second one that I made was with 5. So now I had 5 plus 3 and 5 plus 2, and this time I had 5 5s are 25, 3 5s were 15, I had 2 5s were 10, and I again had this 6. So I had 3 by 5 here, 2 5s here when I turned it over, and the last one that I showed was that pinky looking one, which was 8. And again, this time, eight squared is 64, 3 eighths was 24, 2 eighths is 16, and again I had this 6. So what I've got is, so this side is 11 and this side is 10. This side is 8, this side is 7, this side is 12, this side is 13. So for example, with 13 multiplied by 12, I've got 100 plus 30 plus 20 plus 6. And I often say to students, add these tens because they are the same size unit together. So I've got 156. Over here, I've got a 10 and a 15 is 25. So I've got 25, 25 and another 6. So there's my 50. So the answer must be 56. So that's 7 eighths, 8 sevens is 56. And lastly, I've got this one here, so 24 plus 16 is 40, so I've got 64 plus 40 plus 6, 6 and 4 is 10, so that makes 70. So now I've got 70 plus 40, which is 110. And that's what is 11 multiplied by 10. So the next step is actually almost logical, isn't it? Right? Because everywhere, every picture, what do you notice? There was always this 6 here, right? That 6 was always there. So it didn't matter what number I used. So I could have any number plus 3 and any number plus 2. And I will always get x squared. Here I had 10 squared. Here I had 5 squared. Here I had 8 squared. So this piece is always going to be a square of size x, whatever that x is, what's the size of the unit. Here I've got 3x, so I had 3 10s, 3 5s, 3 8s. And here I've got 2x, we don't write x2. So 2 10s, 2 5s, 2 8s. And I've always got this last piece, which is 6. So if we think about a length and a width of this rectangle, the length and the width is the area, and that is the sum of the pieces inside it. So it is x squared plus 2x plus 3x plus 6. It is x squared plus 5x plus 6. And there's my 5x because they were the same size unit. So algebra tiles are great. Really, really, really good for students to learn with. Make sure that they actually understand it with numbers first and can see the patterns. Hope you enjoyed watching this video. Thanks for watching. Everybody's a maths hero. Till next time, bye for now.